In today's session, we are going to find the particular solution of the given differential equation. Hi, I am Syed. Welcome to my channel Educate with Syed. Let's get started. For this given differential equation, we need to find out the particular solution satisfying these two conditions. Let us try to separate the variables for this given differential equation. Keeping this dy as it is, all the other terms are in terms of x, so therefore let us just try to cross multiply that dx on the other side. So this term remains the same, 2x square plus x, and dx is being cross multiplied there, and x cube plus x square plus x plus 1 also you can just cross multiply. It becomes divided by x cube plus x square plus x plus 1. The variables are separated, you can just integrate it. So if I apply the integral, it is integral of dy is equals to, it is integral of 2x square plus x divided by the denominator term is x cube plus x square plus x plus 1 times of dx. However, we cannot solve this problem directly by substitution method. We will solve this by partial fraction method. So for that, let us try to see, can we just factorize the denominator over here. So we have integral of 2x square plus x divided by, so in these two terms, what is common? X square is common. So if you remove x square as common, what will be left out? X plus 1. Again, group the last two terms, x plus 1. What is common? Just 1 is common. You have x plus 1 times of dx. This can be further written as, it is integral of 2x square plus x divided by, what is common over here? X plus 1 is common, right? So what will be left out here? X square is left out over here, and then plus 1 times of what? Times of dx. So on the left hand side, it is integral of dy is y, and you need to add the constant of integration c over here. Now we are left out to only evaluate this particular integral. So we'll try to evaluate that integral. Let me take this as the equation number 1. Now we need to just evaluate this one. So to evaluate this particular integral, that is 2x square plus x divided by x plus 1 into x square plus 1 times of dx. So let us take only this particular expression. So let us use the partial fraction method. So we have this expression 2x square plus x, it is divided by how much? X plus 1 into x square plus 1. So that will be equals to. So if you try to see the first term over here, x plus 1 is a linear term, therefore we can write it as a by x plus 1 plus. If you try to see the next term, x square plus 1 is a quadratic term, therefore we can write this as bx plus c divided by x square plus 1. So when you have a quadratic term, you have to use bx plus c. Let us take the LCM over here. LCM over here is x plus 1 into what you have, x square plus 1. Just try to cross multiply this one. It is a times of what you have, x square plus 1 plus, again cross multiply, it is bx plus c times of x plus 1. So just cross multiplying, we get this expression. On the left hand side, this value will be the same, there is no change, divided by x plus 1 into x square plus 1. So the denominator will cancel out on both the sides. We are left out with 2x square plus x is equals to, it is a times of x square plus 1 plus it is bx plus c times of x plus 1. So we need to find out the values of a and b, and after finding out we need to plug in the values of a and b in this equation. So let us take this as equation number 2, and let me take this as equation number 3. So to find out the values of the a, b and c, let us make some substitution over here. Let me put the value of x to be equals to, since you have x plus 1, so if you want to make this as 0, let us put x to be minus 1, so that minus 1 plus 1 will be 0, and we can just find out the value of a. So put the value of x to be equals to minus of 1 in this equation number 3. So we get 2 times of x value is minus 1 whole square plus x value over here is minus of 1 is equals to a times of x value is minus 1 and it is squared plus 1, plus you have b times of x value is minus of 1 plus c. Then you have x value is minus of 1 plus 1. We see that minus of 1 and plus 1 will cancel out, therefore this term is 0. So 0 multiplied by anything will be 0. This whole of this term will become 0. And here we have it is 2 times of minus 1 whole square, because it is even power. Minus 1 whole square will give us only 1. And here you have plus into minus will be minus of 1 is equals to, it is a into minus of 1 whole square, because you have even power over here. The negative value will become positive. You will get 1 here plus 1. Plus this complete term has become equals to 0. So let us try to simplify this one. 2 times of 1 is 2. So 2 minus of 1 you have is equals to. So 1 plus 1 is 2. So 2 times of a. So 2 minus 1 is 1 is equals to 2 times of a. Let us try to cross multiply that 2 on the other side. We will be getting 1 by 2 will be the value of a. So hence the first value you got the value of a to be equals to 1 by 2. Now we need to find out further the values of b and c from this equation 3. In this equation number 3, we will just try to put the value of x to be 0. So if you put the value of x to be 0, then in that case we can find out the value of c. We can find out the value of c. So let us see what happens if you put the value of x to be 0. Put x is equals to 0 in equation number 3. So equation 3 you can see over here, it is 2x square plus x. So it is 2 times of 0 plus 0 it is. So it is 2 times of x square plus x is equals to, it is a times of, you can see over here, a times of x square plus 1. This is a times of x square, that is 0 square plus 1, x square plus 1 plus b times of you have x plus, so we have b times of x value is 0 plus c times of what we have, times of x plus 1 is there, but the value of x we have taken it as 0, so we will be getting 0 plus 1. So let us try to simplify this one. This entire left hand side will be 0 is equals to, it is a times of, you can just ignore 0, you are just left out with 1 here. This b times of 0 is 0, you can ignore that one, we are left out only with c, and here with 1. So c times of 1 will be c. So this is 0 is equals to, a times of 1 is a plus c. But what is the value of a we have? A we have calculated as half. So let us just try to plug in over here. 0 is equals to half times of c. Or if I send this half on the other side, becomes minus of half is equals to c. So hence we have got c to be equals to minus 1 by 2. That is the next value we have, c value to be equals to minus 1 by 2. Now we need to calculate the value of b. Now the question is how to find out the value of b. So to find out the value of b, you can see that this bx is being multiplied with x. So if you multiply it, you will be getting the value to be equals to bx square, right? You can equate the coefficient of x square over here. That is one option you have. Again, if I try to multiply this bx with 1, so we'll be getting plus bx into 1 will be bx. So you can even equate the coefficient of x. So any one you can do it. Let us try to equate the coefficient of x square terms. So let us see what are the x square terms over here. This is one x square term here. This is another x square term over here. And here, this value is an x square term. So there are three x square terms over here. So let us try to equate it. First coefficient of x square is 2. So we are going to equate the coefficient of x square. So let me rewrite this equation 3 over here. Equation 3 is, so we have coefficient of x square to be 2 over here. In this case, coefficient of x square is just a over here. As we have seen earlier over here, one more coefficient of x square is only b. So coefficient of x square over here will be b. So let us try to equate the coefficient of x square. Equate coefficient of x square. So we get the value of 2 to be equals to, here coefficient of x square is a, here the coefficient of x square is b. So a plus b. But we know the value of a to be equals to half. So just try to plug in this value of a over here, which is nothing but half, and plus b value as it is. So send this half on the other side. This plus half will become a minus of half is equals to b. Let us take the LCM as 2 over here. So it is 2 times of cross multiply. 2 times of 2 will be 4. Minus of 1 is equals to b. So 4 minus 1 will be 3. So we'll be getting 3 by 2 is equals to b. So we have got the value of b to be equals to 3 by 2. So we have got all the three values a, b and c. We need to plug in all these three values back over here in this equation number 2. So let us just try to plug in these values of a, b and c in this equation number 2. So then we will be getting the expression as, so equation 3 can be rewritten in this form after substituting the values of a, b and c. Let us try to rewrite this one. 1 by 2 times of, it is 1 by x plus 1 plus, I'll just try to split these two terms, divide each of the term by x square plus 1. 3 by 2 as it is x divided by x square plus 1. And then here minus half, we'll take it as outside and rewrite this as 1 by x square plus 1. Now let us try to integrate. We get integral of 2x square plus x divided by x plus 1 into x square plus 1 times of dx is equals to half times of integral of 1 by x plus 1 into dx plus 3 by 2 integral of x by x square plus 1 into dx minus half times of integral of 1 by x square plus 1 times of dx. This will be equals to half times of integral of 1 by x plus 1 will be nothing but log of mod of x plus 1 plus we have to use the substitution method to integrate this one. So as of now we'll write it as it is. I'll try to integrate this separately. Integral of x by x square plus 1 times of dx minus 1 by 2, and this integral of 1 by x square plus 1 is nothing but tan inverse of x. It is in the form of integral of 1 by 1 plus x square into dx form, which is nothing but tan inverse of x plus the constant of integration c. Now we need to evaluate only this particular integral. So let us try to evaluate this separately, then substitute this back in this particular equation. Let me take this as equation number 4. So we need to evaluate this one. Evaluate integral x by x square plus 1 times of dx. So let us put this substitution here. Put x square plus 1 to be equals to, say, t. Let us try to differentiate with respect to x. So differentiation of x square will be 2x plus the constant differentiation is 0, and differentiation of t with respect to x will be dt by dx. So here you have x dx. So retaining this x as it is, cross multiply the dx. So x into dx will be equals to, it is dt, cross multiply 2, so it is divided by 2. So let us just try to plug in back over here in the given integral. So the integral is x by x square plus 1 times of dx will be nothing but integral of, what is the x dx value? It is dt by 2 whole divided by x square plus 1. What is the substitution we have made? It is t. So if I take this 1 by 2 outside, we are left out with only integral of dt by t. So that is half times of integral of dt by t is nothing but log of mod t. But what is the value of t that we have taken? X square plus 1. So let us plug in that value, and here plus constant of integration c. So this will be equals to, it is half times of log of mod t value is x square plus 1 plus the constant of integration c. So substitute this value back in this equation number 4. Hence, after plugging in this value in equation number 4, we get this particular equation. Let us further multiply this one. We have 1 by 2 log of mod x plus 1 plus, it is 3 by 2 times of 2 will be 4 into log of mod x square plus 1 minus half times of tan inverse of x plus the constant c. That will be the required solution. So this integral value is nothing but your value of y. So therefore you have got the solution as y is equals to this particular expression. So let me take this as equation number 5. Now we need to find out the particular solution of this equation. It is given in the question that y is equals to 1 when x is equals to 0. Let us just try to plug in this value of y as 1 and x as 0 in this equation number 5 to find out the value of this constant c. So therefore we get equation number 5 implies, so y value is 1 over here is equals to, it is half times of log of mod x value is 0, so it is 0 plus 1 plus 3 by 4, you have log of mod x value is 0 plus 1 minus half times of tan inverse of x value is 0 plus c. This 1 is equals to, it is half times of log 0 plus 1 will be just 1 plus 3 by 4 will be getting log of 0 plus 1 will be 1 minus tan inverse of 0 will be 0, 0 times of anything will be 0 itself plus c. But we observe that log of 1 will be 0, log of 1 will be 0. So this complete expressions are 0. So then what will be the value of c? The value of c will be 1. Therefore, if I substitute this value of c back over here in equation number 5, so we will be getting equation 5 as, this will be the particular solution. We can simplify this further. If you try to observe, there are two terms which has log. So let us just try to group this log terms. But here you are having the denominator as 2. Here you are having the denominator as 4. So let us make the denominator as common so that we can simplify this one. So since I want to make the denominator as 4, multiply and divide by 2. Remaining terms will be the same. This is equals to 2 by 2 times of 2 will be 4. You have log of mod x plus 1 plus 3 by 4. It is log of mod x square plus 1 minus half times of tan inverse of x plus 1. So in these two terms, if I take 1 by 4 common outside, I will be left out with 2 times of log of mod x plus 1 plus 3 times of log of mod x square plus 1. These two terms as it is, minus half times of tan inverse of x plus 1. This will be equals to 1 by 4 times of. You can write this as log of mod of x plus 1. If I take that, it becomes power x plus 1 whole square. Because it will be a positive term, so I am removing this mod. Plus we have log of again x square plus 1, and this is raised to the power of 3. And this also becomes a positive value. Minus you have half times of tan inverse of x plus 1. This can further be written as 1 by 4. Is it not in the form of log m plus log n, which will be log m into n. So we get log of x plus 1 whole square into x square plus 1 whole cube minus half times of tan inverse of x plus 1. If you like my video, please subscribe to my channel. For today's session, that's all I have. Thank you.